Today, we do section 8-1. How did you get my glasses? Give those back to me. Good grief. Yes, section 8-1. All right, let's start with an old, simple concept here. You know how to factor that. You can factor that in your sleep. Maybe you have in your nightmares. I don't know. There are two ways to factor, of course. One is to apply the RAP test. Since we've been in quarantine, I don't know if we've ever reviewed the RAP test. Maybe we have. The RAP test says what? If that's a square, and that's a square, then we can apply the RAP test. Can't snap my fingers, it's too dry. What was squared? What was squared? Multiply and double. What was squared? What was squared? Multiply and double. Yay! Algebra! That's more like a cheer than a rap. But what was squared? What was squared? Multiply and double. The RAP test. What was squared? X. What was squared? 5. Multiply. That's 5x. And double. The answer. That's 10x. Does it match the middle term? If it matches the middle term, you have yourself a perfect trinomial square. And all you have to do is write down what was squared, what was squared, match the sign, you're done. What was squared, multiply and double. If it matches the middle term, you've got it, you're done. Of course, you could use it by just the old method. Oh, let's say we need two things to multiply to give x squared. What could they be? Let's try x and x. I think so. How about the 25? It could be 1 and 25, or it could be 5 and 5. Let's try 5 and 5. Yeah, because 5 times 5 is 25, 5 plus 5 is 10. Yeah, you've got it. Oh, we could have written x plus 5 quantity squared. Yes, we could have. All right, you know how that works. All right, I'm writing a test, and I want to create a problem like that. Back for chapter 2 or 3 or something, I'm creating a test. And as I'm writing the test, I'm thinking, okay, I want this to be a perfect trinomial square. What do I need to put here for my last term to make it a perfect trinomial square? Of course, we know it's going to be 25, but suppose we didn't already know that. Well, remember, it's what was squared, multiply and double, and we get this. What was it right before we doubled it? It would have been a 5. And 5 squared, 25. We know that will work. What if this had been this? Then if I want to put a number here that will make this become a factorable perfect trinomial square, what do? Well, half of 12 is 6. 6 squared is 36. Does that work? Well, yeah. What was squared, multiply, and double. Yeah, it works. So to figure out what number I'm going to put here when I'm writing my test, if I want it to be one of these kind of problems, all I have to do to figure out what to put here is I take half of 12 and square it and stick it there, and I know it'll work. That is called completing the square. So, we see a problem like this. And the instructions simply say to complete the square. Oh, that's the one we just did, isn't it? Yes, it is. If it says complete the square. Now, I am not claiming that this is equal to the original. No, it's not. It's kind of like, what's it like? It's like saying, okay, I got 15. Let's make that into a square. Let's complete the square. How about if we add 1 to it? Okay, now it's a square. What do I add to this to make it a square? Half of 12 being 6, 6 squared is 36. If I add 36, it's not what it used to be, but I have completed the square. I have made it into a square when before it was not a square. Now it is. X plus 6 squared. What if this had been a minus? Well, you know, half of negative 12 is negative 6. Negative 6 squared is still 36. Does that work? What was squared? What was squared? Multiply and double. It matches. I would have x minus 6 quantity. It still works. Whether that's a plus or minus makes no difference. You still complete the square the same way. Take half of this guy and square your answer and tack it on the end. Oh, this is so easy. Complete the square on this one. Half of 20, 10, squared, 100. We just completed the square. If we wanted to factor that now, it would be x minus 10 squared. Done. Once you've completed the square, factoring becomes really easy because, well, we cheated. We rigged it. We rigged it to be easy by completing the square. Now this guy is a little trickier. Let's complete the square on this dude. Okay. Well, we've got to take half of 3/4. How do you take half of 3/4? Well, remember, of means multiply. And you've known how to do that since about 3rd grade, maybe 4th. 1 times 3 is 3. 2 times 4 is 8. It's 3/8. Oh, so we add 3/8? No, we have to square it, remember. So we're not going to add 3/8, we're going to add 9/64. 9/64. We just completed the square by taking half of 3/4, which is 3/8. By the way, that's the shortcut for taking half of any fraction. Just double the denominator. So we have 3/8 squared is 9/64 added on there. You have completed the square. So how would you factor that? Oh, that's going to be hard. No, we rigged it to be easy. Why? Match the sign plus, well, what did we square here? We squared 3/8. That's all. 3/4 doubled. I'm sorry. No, half of 3/4, or the square root of 9/64. What did we square to get 9/64? 3/8. Done. Now, we take the next step now, a quantum leap, as we might say in chemistry. Let's solve this equation by completing the square. First, take note. You can try all day if you want to, and you're not going to be able to factor this thing. So if we can't factor it, what do? We will solve it by completing the square. By the way, did I have a note on that previous screen? Down here, perhaps, I forgot to read. No, there was no note. Okay, moving on. All right, so we're going to solve this thing by completing the square. Here's your procedure. This is great. This is the big deal for the day. This is the big deal for the day, so tune in carefully here. Here we go. Your procedure. Step 1. Is this a perfect trinomial square? Well, no. That negative 5 especially, is not a square. So step 1, get that negative 5 out of there. It's bothering us. It's in the way. Let's add 5 to both sides. There. It's out of our way. Now we're going to take what's left over here, and we're going to complete the square. How do we complete the square? We take half of this guy and square the answer. 1, and 1 squared is still 1. So I'm going to very cleverly add 1. But wait a moment, this is an equation. I can't go around just adding 1 to one side unless I add 1 to the other side as well to bring the scales back into balance. So I add 1 to both sides. A common and unforgivable mistake I see students make on this is they'll add 1 to one side and they'll forget to add it to the other side. How can you forget that? You can't let your scales get out of balance. If I add 1 here, I've got to add 1 there. All right, so what do I have now? The beauty of this is, by the way, We just rigged it to be easy. You almost feel like you're cheating. We rigged it to be easy because we can factor this thing now. How do we factor it? X, match the sign. What squared gives 1? There. Equals 6. What do I do now? This problem's a little more involved than the others have so far been, and all this stuff is going to be a bit in the way. I need to move all this down. One moment. Get this out of the way. Little case of poor planning here. Get that down farther. Okay. Now. There. All right, so what do I do now? I have, whoops, didn't mean to do that. I have something squared equals 6. How about if I start by getting rid of that exponent? Let's take the square root of both sides. Square root of x minus 1 squared is x minus 1. Square root of 6 is, and once again, what mistake, what tragic mistake did I just make? When you take the square root of both sides of an equation, you must take into account both the positive and the negative square roots. That is required. That is not optional. That must be done. But I don't have x quite by itself yet. So my last little detail, I've got to get rid of that minus 1. Well, isn't that kind of easy? Yes, that's easy. Add 1. Plus or minus square root of 6 plus 1. However, there's an old tradition that says we would really rather have that plus 1 on the other side and have the plus or minus in the middle. So we choose, due to tradition, we choose to write it as 1 plus or minus square root of 6 by putting the positive 1 on the other side. So this is actually two answers. It's 1 plus the square root of 6, or it's 1 minus the square root of 6. Two separate answers, written the easy way. All right, let's solve this guy by completing the square. When I created this problem a little while ago, it occurred to me after I created it, because I made it deliberately to be easy, I thought, oh, you know, we could have just solved this by factoring. X plus 3 and x plus 7, the solutions are negative 3 and negative 7. That was easy. Completing the square is more helpful when the problem can't be factored. This one is easily factored, so why would we bother completing the square? We wouldn't. But for right now we will, because you need practice in completing the square. So, let's go ahead and do it by completing the square, see if we get the same answers, negative 3 and negative 7. We'd better. Alright, that 21, that's not a square, get it out of there. X squared plus 10x equals negative 21. There, that's better. Let's go roll this. Alright, so we got the 21 out of the way. Now we complete the square. How do we complete the square? Same way as always. Half of 10 is, square that. Yep, that's 25. We add 25 to both sides. To both sides! And now, once again, the beauty of it is we have rigged it to be easy. Factoring this is trivial. It's x plus 5 quantity squared. X plus 5 squared is, whoops, what happened? Okay, is 4. Now I'll take the square root of both sides. So x plus 5 is the square root of 4, which is, watch out, it is not just 2, it's plus or minus 2. Now I subtract 5. So x is, and I'm going to write it in the more traditional order. Instead of writing minus 5, I'm going to put negative 5 plus or minus 2. I'm not quite done because that can easily be simplified. I do get my two answers. What are they? What's negative 5 plus 2? That'll be negative 3. And negative 5 minus 2 is negative 7. And sure enough, I got the same answers we got by doing it the easy way. So why did we do it the hard way? Because there are problems that can't be done the easy way. More about that a little later. All right, this guy, let's complete the square. By the way, can we solve this? Oh, sure we can. No, we can't. This cannot be solved. Why not? It's not an equation. Only equations can be solved. This is not an equation. There's nothing here to solve. There's not even anything here we can simplify. But because we're practicing, we can complete the square. So how do we complete the square? We're going to add something. What are we going to add? We take half of 3/4. Do you remember the trick for taking half of a fraction? Just double the denominator. So half of 3/4 is 3/8. Take the 3/8 and square it. We get 9/64. There. I just completed the square. Now it is indeed a perfect trinomial square. And factoring becomes trivial. As ugly as it looks, factoring is trivial. We have y, match the sign. What was squared? 3/8. Don't forget your exponent, you're done. Let's solve this guy by completing the square. This is an example where we would not be able to, hi, goodbye. An example where we would not be able to factor it. Let's do it by completing the square. Oh, by the way, there could be some smarty pants students out there who are saying, Mr. Peer, there's an easier way. What about the quadratic formula? We're not quite there yet, but in the next video, we'll be doing the quadratic formula, so hang on. For now, on this assignment, you are not to use that newfangled fancy quadratic formula thing. We're pretending you don't know it yet. On the next assignment, you must do them by completing the square. No shortcuts allowed. All right, let's complete the square. First of all, that -5 is just plain wrong. Get the -5 out of the way. We will add 5 to both sides. Now we'll complete the square. Now and only now. Once that guy is out of the way, we've got a big blank spot here. Now we'll complete the square. Half of 2, 1. 1 squared, 1. I will add 1. And since when can we go around just adding 1 to an expression? Since we had an equation. Because it's an equation, I can add 1 to the left side as long as I keep the scales balanced. Yes, don't forget to add it to both sides, otherwise you butchered the whole thing. Now factoring this again, my word of the day. What's my word of the day? It starts with T. Yeah, it's trivial. Factoring is trivial. I know it's going to be a binomial squared. It's got to be x. Match the sign. What was squared? Done. Equals 6. Almost done. I now need to get rid of the exponent. Remember the order of operations, PEMDAS? We're not putting things together. We're solving an equation. We're taking things apart. So we reverse PEMDAS. That which would normally be done last, because it's outside the parentheses, will be undone first. Remember, what's done in parentheses is done first. Therefore, the exponent would be done last if we were doing it, but we're not doing it, we're undoing it. What would normally be done last gets undone first. So we take the square root of both sides. X minus, oops, make that look better. X minus 1 is what? Plus or minus square root of 6. First time I didn't pretend to forget the plus or minus. And now what do we do? We're basically done. Add 1. X is 1 plus or minus square root of 6. Yes, we prefer to have the 1 over there rather than having it over here. Mathematical tradition, we would rather have it over here. That's it. We're done with that one. Follow the green arrow. There we go. This example is, I believe, our last example. Yes, it's our last example, and it's extremely important. I'm a little surprised the book writers only gave us one example like this. It is extremely important and has caused losses of points among students for years. See that 4 sitting in front of the x squared? Ooh, can't leave that there. That will mess you up big time. You must not have any coefficient of x squared other than a 1. Notice in all the previous examples, there was nothing in front of the x squared, nothing in front of the y squared, nothing in front of the x squared, nothing in front of the x squared. In all of these examples, nothing in front of the x squared. But in this one, we have a 4. We've got to get rid of it first. We're going to divide the whole equation by 4. Divide by 4. Divide by 4. Divide by 4. Divide by 4. Remember, you can only divide by 4 if you're going to do it on both sides. Keep that equation balanced. But what is 0 divided by 4? It's still 0. It's one of those times where you could get away with misunderstanding terribly and still end up with the right answer, because if you forget to divide this by 4, it's not going to make any difference. All right, from there, let's get rid of that minus 7/4. We could have gotten rid of the minus 7 to start with, and then divide by 4. Or divide by 4 first, and then add the 7/4. Either way, it doesn't matter. You can divide by 4 as your first step, or you can get the 7 over here, and then divide by 4 as your second step. It doesn't matter. Try it both ways, and you'll quickly see what I mean. So we now get that minus 7/4 out of there. Add 7/4 to both sides. Now we complete the square. Oh, Mr. Bear? Yes? How do you take half of 3? Oh, come on. You can take half of 3. You know, the easiest way to take half of 3 is stick a 2 under it. We just took half of 3. Because after all, half of 3 means what? It means half times 3, or 1/2 times 3 over 1, which is 3 over 2. 3/2. Just put a 2 under it. So we take half of 3, which is 3/2, and square the answer, that's 9/4. We will add 9/4. Yeah, I heard you. Okay, good. And add 9/4 over here also. Where did the 9/4 come from? We took half of 3 by sticking a 2 under it and squared that. That's 9/4. That's what we add to both sides. If you know the procedure, I mean, seriously, it's easy if you just remember the procedure. Again, my word of the day, yeah, you know it now. It's trivial. X, match the sign, do this in your sleep. What was squared? 3/2. Don't forget your exponent. Don't even have to think about what you're doing. That's trivial. We rigged it to be easy. On purpose. 7/4 plus 9/4. Don't you dare tell me it's 16/8. 7 of these guys plus 9 more of those guys doesn't give you 16 of something else. It gives you 16 of those guys. Hey, let's just go ahead and use the eraser method and get rid of that 16/4 and change it into a 4. And now you can see what's going to happen, how simple this becomes. We take the square root of both sides. X plus 3/2 is what? Plus or minus 2. Plus or minus the square root of 4. Plus or minus 2. And we haven't quite gotten x by itself yet. So now we still have to get rid of that 3/2. So we will subtract 3/2 from both sides. Now we do have to simplify this. There are no radicals involved. It's not irrational. So I do expect you to simplify this thing. This is plus or minus 2 over 1. But you know how to work with fractions. You've got to have common denominators. 2 over 1 becomes 4 over 2. So now we have negative 3/2 plus 4/2. Negative 3/2 plus 4/2 is 1/2. And then negative 3/2 minus 4/2 is negative 7/2. We're done. It's over. you could plug in those two fractions back into the original equation. They would work. I'm tempted to do it now, but I'm afraid you'll just click stop on the video and quit. But yeah, it's not a hard thing to do. So we're done. 1/2 and -7/2. Okay, and that brings us to the assignment. Yeah, 4 measly problems. It would have been more problems than that, except for the fact that I decided to take this section and break it into 2 parts. That's why this half of the assignment is so short. It's not because they're super hard, it's because it's just a short assignment. 346 part 2. Please, when you turn this in, please designate it as being page 346 part 2. That makes it much easier for me to sort these things out. Numbers 40 through 46 even. And just a hint on number 46. On number 46, start by multiplying everything by 2, and your life suddenly becomes really easy. And you'll say, "Oh, bless your heart, Mr. Beer, thank you for that hint." Yeah. You multiply everything by 2, your fraction goes away, and everything is just like all the others. Very simple. They tried to trick you, but, well, they can't trick you because I just told you how to handle it. Multiply by 2 for number 46. And all of these are to be done by completing the square. If you use the quadratic formula, or perhaps you factor because it's easy to factor, then no. I'll just write you a message, say try again for a lower score because you weren't paying attention. Okay, you must solve these by completing the square. Okay, that's it. We're done with this. And next time, the next video, we will go over these 4 measly problems. And then we'll be able to dive into the great and famous quadratic formula. The last concept of the year. Wow, we've arrived almost. Goodbye.